Hey guys, welcome to Spark STEM Scholars. Today we'll be going over exponents and radicals. These concepts are extremely important in SAT math, and let's get started. So first, let's go over some rules. So laws, and then we'll put some examples on the side. Okay, anything to the first power will equal to itself. So let's say, for example, 3 to the first power will equal to 3, and like any numbers, 49 to the first power will equal to 49. So that's our first rule. Now, anything to the 0 power will equals to 1. So the base number, if you have 10 to the 0, then you will have 1. If you have 12 to the 0, then you also have 1. So anything to the 0 power is 1. Next, if x to the m times x to the n, then so the multiplication rule, it will be equivalent to x to the m plus n. So let's say we have 2 to the 4th times 2 to the 5th. Then this will mean that it is equivalent to, when you solve this, you can do 2 to the 4 plus 5, which also equals to 2 to the 9. These are all equivalent to each other. Oh, I keep forgetting to change color. Let me change this color. Okay, next we have the division rule. So x to the m over x to the n, it is equal to x to the m minus n. So let's take a very similar example to the last one. 2 to the 7th over 2 to the 3rd, we would have 2 to the 7 minus 3, and that would equal to 2 to the 4th. And these three are equivalent to each other. So next up, we have power over power rule. The general rule of power over power rule is if x to the m to the n, this way equals to x of m times n. So m and n will multiply each other. So let's take a look at an example. We have 2 to the, let's take 2 to the 4th and parentheses and everything to the second power. So this would mean that it will be equivalent to 2 to the 4 times 2, which is 2 to the 8th. So next up, we have power of a product rule. What that means is that if you have x and y parentheses and everything to the m, it is essentially x to the m times y to the m. So let's take a look at another example. So 2 times 3 and to the second power, that will equal to 2 to the 2 times 3 to the 2. And up next, we have power of a quotient rule, x over y to the m, that is equal to x to the m over y to the m. So let's have 2 over 3 to everything to the power of, let's go with 2 again. And this will equal to 2 to the 2 and 3 to the power of 2. Our last rule will be x to the negative m, and we have a negative exponent. It means that it's a fraction. So it'd be 1 over x to the m. So if you have 4 to the negative 2, then this will basically be 1 over 4 to the 2. So these are the rules that you need to memorize by heart. And once you memorize it, it will make things a lot more easier. Let's look at some common mistakes. So many students do not know the difference between this and this. Or actually, I can just write it as 3 to the second power. Order of operation, PEMDAS. Hope you guys know what that is. So it dictates that parentheses takes priority over exponent. So that means that parentheses -3 to the second power, this is equal to -3 times -3, which you would get 9. And on the other hand, without the parentheses, the exponent takes precedence. So -3 to the second, you will have a negative on the outside, and it will be -3 times 3, and that would equal to -9. But that doesn't mean that they will always have different answers. Typically, if you have a negative base and if you have an odd exponent, so let's take another example. If you have an odd exponent, let's say -2 to the third and -2 to the third. If you have an odd exponent and a negative base, if you evaluate it, the result would turn out to be the same because -2 times -2 times -2, that is equal to -8. And -2 times 2 times 2, that's also 8. So if you have an odd exponent with a negative base number, then it will yield the same result as if you don't have parentheses. Let's try some exercises. I want you to pause the video and try these on your own, and then we can go over it together. Okay, so -1 parentheses to the fourth power. That is -1 times -1 times -1 times -1, which is just 1. And for the second question, we have 3 to the 0. And if you remember your rules, anything to the 0 is equal to 1. So the answer for 2 is 1. And then for number 3, 2 to the 3 is 2 times 2 times 2. 2 times 2 times 2. That is 8 times 3 to the second power, which is just 3 times 3. That is equal to 9. And times -1 to 5 to the fifth power. And like I said before, if you have a negative base to an odd power, then you will have a negative result. This is -1. So times -1, and 8 times 9 times -1, that is -72. Now, 10 to the -3, then you will have 1 over 10 to the third power. And that is just 1 over 1,000. A tip for this is that if you have a base number of 10, if you have a base number of 10, then your exponent is basically just telling you the number of zeros you have. So in this case, we have 3 zeros, that is 1,000. And up next, finally, we have 5 to the 6 over 5 to the 4th, and that you can just use the quotient rule. So which is 5 to the 6 minus 4, that's equal to 5 to the second power, which is just 5 times 5, and it's 25. It's simple right now, isn't it? Let's try exercise 2. Pause the video and attempt these yourself. So let's start going over this. Number 1, 2 times k to the negative 4 times 4k to the second power. So first, 2k to the negative 4, if you have a negative exponent, that is a fraction. So since 2 is non-negative, it's just 2 over k to the 4th times 4, 4k squared. And if you multiply that, then you have 8k squared over k to the 4th. And we can simplify this further into 8k to 2 minus 4, which is equal to 8k negative 2, and that would be 8k, 8 over k squared. Now, number 2, 3x squared times 2x cubed. Since we have the same variable, then we're safe to multiply these together. 3 times 2 equals to 6, and that would be x to the 2 plus 3, and that is 6x to the 5th. This one is a little bit more work, but it is pretty simple. So you distribute the exponent of 3 to both variables. We distribute, it is 2 times 3, so it would be m to the 2 times 3, that is 6. And that's n to the 3rd. And doing the same for the bottom, then it will be m squared and n to the 4th, because 2 times 2 equals to 4. And then now we can further simplify this into m6 minus 2, that's 4, so that's m to the 4th. And then since 3 minus 4 is negative 1, then n will be in the denominator. Answer is m to the 4th over n. Let's try some word problems. If 3 to the x plus 2 equals to y, then what is the value of 3 to the x in terms of y? So let's avoid the trouble of finding what x is. We notice that the 2 in the exponent is the only difference between the given equation and what we want, which is 3x. So using our law of exponent, we can take the 2 out. So 3 to the x plus 2, 3 to the x times 3 squared. And all of this is equal to y. And moving the 3 squared to the other side, we divide. So it would be 3 to the x equals to y over 3 squared, which is equal to y over 9. Let's try which of the following is the equivalent form of x squared to the 3/4 power, where x is greater than 0. So you can pause the video and try this yourself. So let's write out our expression. So first, you can use the product rule where you can multiply 2 and 3/4. And 2 times 3/4, it is equal to 6/4, which you can also simplify it to 3 over 2. So right now you have x to the 3 over 2. And we didn't go over this before, but if your exponent is a fraction, then that is equal to the radical root of the denominator and x to the m. So this is pretty important to know. We can also separate the fraction. It's equal to 2 over 2 plus 1 over 2. And that is equal to x to the first power times x to the 1/2. So this will equal to x square root of 2, which is b. Thanks for watching, guys. That is all for today, and I'll see you in the next video.